calculus is further divided into two parts. They are integral calculus and differential calculus. Let us start with differentiation. Before that, we must know what is a function. Y is equal to f of x. To understand this, consider the square of side x. Let the area of the square be y. Consider the area of the square be y. Then y is equal to x square. We know that area of the square is side square. So y is equal to x square. If x is equal to 1, that is the length of side is 1, then the area of the square would be 1. Then area of the square will be 1. And if x is equal to 2, area of the square y is equal to 2 square, that is 4. If x is equal to 3, y is equal to 3 square, that is 9. And if x is equal to 4, y is equal to 4 square, that is 16. And if x is equal to 5, y is equal to 5 square, that is 25. Now let us plot these values in a graph. If x is equal to 1, y is equal to 1, somewhere here. 1, 2, 3, 4. This is the x-axis and this is the y-axis. If x is equal to 1, then y is equal to 1. If x is equal to 2, then y is equal to 4. So let us plot a point like this. If x is equal to 3, then y is equal to 9. Then let us plot a point like this, just above 8. This is one point, this is one point. And this is one point. And if x is equal to 4, then y is equal to 16. This is equal to 4, y is equal to 16. And if x is equal to 5, y is equal to 25. Just about 24 like this. Now let us join all these points. It would look like this. Let us erase the extra lines. Now the graph looks like this. The area of the square varies as the side varies. Let the side be x and the area of square be y. So y varies as x varies. So y is equal to f of x is said to be a function of x because it varies along with x as x square. If x value is varied, then y value is also varies. Y is equal to f of x, that is function of x. Here function is not the function which we go to a parties like that. Function means the value of y varies according to this function, that is x square. In the case y is equal to f of x is equal to x square in this case. It may be 2x in case of a straight line or like this. Now let us consider a straight line like this. Take a graph and let us consider a straight line like this. Now the slope of this graph, if this angle is theta and this is x-axis, the slope will be tan theta. For a straight line, this is the slope. At this point P, the slope is tan theta, and at this point Q, the slope is tan theta. In case of a straight line, the slope is constant. But consider this graph which we have drawn earlier. Let us consider this point. Let us draw a tangent to this curve at this point. Extend it. The angle made by this tangent at this point be theta. Then slope of the tangent will be tan theta. at that point. But if we see this point, the tangent will be like this. Extend it, the angle will be some alpha. Slope of the graph at this point is tan alpha. At the point P, it is tan alpha. At the point Q, the slope is tan theta. For a curve like this, the slope varies from point to point. For a straight line, we have a constant slope. So, how can we find a slope at the point for the curve? Always we cannot draw a graph and check the angle between the tangent and x-axis. So, we use differentiation for this purpose. So, the slope of the graph at that point is given by dy by dx. That is differentiation of y with respect to x. Don't consider it is dy divided by x. Don't consider this as dy divided by dx. It is the wrong process. It is a function like this, d by dx of y. We must not cancel d like this. It is a function like that. It is equal to, if y is equal to f of x, then dy by dx is equal to f dash x. That is differentiating y with respect to x is called the differentiation. So let us see its practical use. Okay, consider this. You are moving from your home to the college. That is in a car. You are moving from your home to college in a car, and the distance between your home and college be x. Let the distance between your home and college be x, and the time taken to travel from your home to the college be t. You can measure the time taken to travel from your home to college. Let it be t. Then the speed with which you went to the college will be, speed is equal to x by t. The speed with which you went to the college is x by t. This is so longer distance. So let us consider some part of your journey. Let us consider this is a bridge in between starting point of the bridge and ending point of the bridge. And let the length of the bridge be delta x. And the time taken to cross the bridge is delta t. Then speed of your vehicle when you are crossing the bridge would be, average speed when you are crossing the bridge would be delta x by delta t. This delta x is smaller than the total distance between your home and college. This is just a part of the journey. This is the length of a bridge. Then average speed maintained between the starting of the bridge and the ending of the bridge is delta x by delta t. Let us take still small distance like this. This would be dx. At that instant, infinitesimally small distance. Infinitesimally means very, very small distance. Then what is your velocity? Instantaneous speed or velocity can be found by dx by dt. That is differentiation of the distance with respect to time. At that instant, what is the velocity? We can find the instantaneous velocity at that point by differentiation dx by dt. At this it is an average one because the length is longer. We know the starting point, ending point, and the instantaneous velocity between these may be changing, but the average speed is constant. At this instant the speed may be 1, at this instant the speed may be different, like that. This is so we can understand the difference between average speed and instantaneous speed. with instantaneous velocity. The velocity at that instant will be found by differentiation. This is an application of differentiation. Similarly, we can find the slope of a curve using differentiation. Let us consider the previous example.